Hi everyone, I'm Fiona Fiddler and welcome to repliCATS. Thanks for signing up to do a workshop with us. This first video gives a very quick background to the repliCATS project and the broader SCORE program that repliCATS sits within. First, to say we're a very big interdisciplinary team based predominantly at the University of Melbourne, but with collaborators in the Netherlands and the UK and the US, all working together for collaborative assessments for trustworthy science. So repliCATS is funded under DARPA's SCORE program. It's two acronyms very close to each other there. SCORE stands for Systemising Confidence in Open Research and Evidence, and DARPA is, well, the grant funding agency of the US Department of Defense. One of the interesting things about repliCATS and SCORE more broadly is that it is funded by end users of research, decision makers who want to know that the social science evidence base that they are relying on, often in the case of DARPA for literally life and death decisions, is a sound and reliable evidence base. Previously, most of this kind of work around replication projects or meta-science research has been funded by various philanthropic organisations. So SCORE marks a real turning point. The SCORE program has three what are called technical aspects. The first technical aspect is coordinated by the Centre for Open Science. So what their job is to curate a data set of the articles that will be used across the program, published research articles. They're also responsible for coordinating replication and reanalysis studies that become the ground truth for what we're doing in technical aspect 2, which is eliciting human expert predictions about the likely replicability and now other aspects of credibility of published research. There have been two teams in this aspect of the program, us, the repliCATS team, and in phase 1 there was a second team, KeyW, who ran a replication markets, a prediction market. The third technical aspect of SCORE is the blue sky part of the project that DARPA is famous, the kind of research that DARPA is famous for. And the purpose of this, there are 3 teams in this aspect, all working to build machine learning algorithms that control the published research literature and assign confidence scores to the published evidence. These confidence scores then can help guide end users, decision makers, about how appropriate this particular piece of evidence might be. So, in repliCATS, we're not running a prediction market. We are using a structured elicitation protocol called the IDEA protocol, and you'll hear a lot more about this in the expert elicitation video. For now, suffice to say that we are using the wisdom of the crowd, but not in a prediction market way. Our method is more of a modified Delphi process, with one important change, that we are not looking for group consensus. We have groups that interact, question each other, share information, interrogate each other's judgments, hopefully listen to each other, sometimes change their minds, sometimes don't, and then we mathematically aggregate their responses. And we calculate confidence scores based on the aggregation of those individual judgments. Now, it would be easy if we could aggregate individual judgments by simply weighting the judgments of the experts who were best at this more heavily. But of course, we don't know who is best at this. Typical markers like years of experience or how many publications you have turn out to not be very good proxies for performance at this task. So instead, we've come up with a whole bunch of aggregation models that rely on other performance proxies, like how engaged our experts are, or the extent of the reasoning that they provide to justify their judgments, the certainty or uncertainty they express in their interval judgments, and so on. And again, you'll hear a lot more about this in the next video. So applying this approach across phase 1, we, or you, our participants, our experts, evaluated the replicability of 3,000 published articles across from 62 journals across 8 different disciplines in social and behavioural sciences. So business, criminology, economics, education, political science, psychology, public administration, and sociology. And we did this by drawing on a very large and diverse participant pool, over 500 participants in more than 40 different countries, running a combination of face-to-face workshops back when we could do things in real life, and also these remote workshops. And we also partnered with some journal clubs too, most notably the Reproducibility Journal Club, who gave up part of their journal club time to run evaluations like the ones that you'll be doing. So for those 3,000 articles, each of them were evaluated by at least 4 people, often 5 or 6 people, and together they returned to us 14,000 individual judgments and over 43,000 justifications for those judgments. It's an extraordinarily large data set. And when we examined how well our groups of experts did in terms of predicting whether or not a claim would replicate, we compared the aggregate judgment from our groups to the replication outcomes of the studies coordinated by the Centre for Open Science. In phase 1, we had 22 different methods of aggregation. Some are linear combinations of the best estimates, simple means, transformed best estimates. A couple of others were Bayesian approaches, but by far the largest category were linear combinations of our best estimates, but weighted by these different proxies for good forecasting performance, like, as I mentioned before, the extent of uncertainty in an interval, or the number of independent reasons people gave us for their judgments. We were assessed by direct replications. There were 50 direct replication studies, data analytic replications, 31 of those. So these are when you take a different pre-existing data set from a similar time period with similar measures and use that as a comparison, and computational reproduction, 78 of those, which repeat the same analysis that's reported in the original published paper to determine whether the originally reported statistical outputs can be recovered. So when we put all of those 3 types of evaluations together, we get the table on the left here. So this is our overall replication outcomes, and there are 3 measures of accuracy reported here: AUC, or area under the curve scores, Breyer scores, which are proper scoring rules, and classification accuracy. So our best aggregation methods, which are these 2 above the red line here, correctly classified successful replication studies about 74% of the time. And they also had pretty impressive Breyer scores and AUC scores too, if that means anything to you. And these 2, the best ones, the ones above this line here, were the ones that weight people's estimates, their quantitative judgments, their probability judgments about the likelihood of replicability, and weight those judgments by the number of independent reasons they gave to support those judgments. If we look at the results, not in this overall sense, but just for the 50 direct replication studies, which is this table here on the right, 18 out of our 22 aggregation methods passed our phase 1 goal, which was achieving an AUC score of 0.7 or above. Okay, so now we're in phase 2 of the project, and based on the success of phase 1, we're feeling more ambitious now, and we have 2 main changes. So the first change is that we're looking at evaluations at multiple levels. So in phase 1, we were focused on just one single claim within a paper. If you think of this strange looking picture here represents a network of claims within a single paper. So at the top, you might have the highest level claim, perhaps the title of the paper, and the next level you have a couple of independent claims, perhaps the claims mentioned in the abstract. By the third level, you're looking at specific individual hypotheses, and then the blue dots right down on the fourth level are individual bits of evidence, individual statistical inferential tests or bits of descriptive statistics that support the higher level claims. So in the first phase, we were focused on just one single one of these level 4 or individual evidence level claims. This time in phase 2, we're looking at we're doing the whole lot. All of the level 4 claims and the overall, well, not all of the level 4 claims, a selected set of level 4 claims and also these overall top level 1 claims. And the second big change is that in addition to replicability, we're looking at multiple dimensions of credibility. So we're going beyond just replicability and working our way up to something that's more like a comprehensive peer review protocol. So for the credibility signals that we're interested in for the overall at that high level claim, comprehensibility, prior plausibility of the claim, transparency of the research, replicability, robustness, validity, generalizability, and an overall credibility rating. So there are 8 dimensions there all together. Then for those individual or level 4 results, we're asking again about credibility. We're also asking about relevance. Relevance here means the relevance of this particular little bit of evidence, this one particular test, its relevance to the overall credibility of the article. So we'll talk more about this when we go through what the exact questions in the workshop will be. Okay, so data collection for phase 2 is ticking along. We ran our first workshop last month at the Society for Improving Psychological Science conference, where we managed to assess 72 papers in one workshop. And now we've moved into a different phase where we're running smaller disciplinary specific workshops like this one. Later in the year, we'll also be offering some larger workshops again, for example, at the AMOS conference in late November, early December. Okay, so thanks again for participating in the workshop, and please do follow up with the other videos up to this. Thanks.